Welcome to part 2. Let's begin. So we're given these questions right here, and these questions are normally quite difficult for students. So we're going to go slowly, and I'm going to be using a lot of visuals just for these beginning ones, but later on you might find that you're able to do them without the visuals. But for now, let's use them. Let's give it a read. It says, if cos of x is equal to negative cos of pi on 6, and we're given this domain right here, find the value of x. Okay, so as I said before, what I'm going to do is I'm going to use a unit circle to help me here. So you might just want to draw yourself a little sketch of a unit circle, and you'll find that this may be helpful to you. So just give yourself a little sketch and we'll see how we go. All right, so the first thing that we're going to do is we're just going to consider this right here. So let's just ignore that negative out the front, and let's just consider that, the cos of pi on 6. Now, that means I'm going to look at my first quadrant, and I'm just going to say that this right here, this is pi on 6. It doesn't have to be accurate. We're just drawing a rough sketch here, and we're going to say that this is A, B. Now, because I'm dealing with cos, that means I'm looking at my x value. So that means we care about the A here, because A is my x value. Let's now rewrite what we've been given, because if we know that cos of pi on 6 is equal to A, we could rewrite this as cos of x is equal to, now don't forget the negative, and then we know that cos of pi on 6 is A. Let me draw that a bit better, like that. Okay, so now we have to think of, well, where's negative A going to be? Well, if I know that this is my x value, right? So this right here, that is the A spot. Well, then negative A is going to be exactly symmetrical. It's going to be over here. This is going to be negative A. And I could draw this up like that, and I could even say, let me get a different color, like that. This is going to be pi on 6. So we're just using our laws of symmetry to kind of get our head around what we're doing here. Now, if we keep on reading, it says, let me get my highlighter. It says that we need to find the value of x, and x has to be between pi on 2 and pi. So we need to find what x is going to be, and it has to be between pi on 2 and pi. So in other words, it has to be in the second quadrant. And if we're dealing with the second quad, so you might even want to write that down. This tells us right here that we're dealing with the second quad. So what that means is that my x is going to be equal to pi minus pi on 6. So remember, the thing that needs to be burned into your brain about the second quadrant is that it's pi minus the angle. And now we're just going to solve that. So I can actually do it down below. It's going to end up being 6 pi on 6 minus pi on 6, which is equal to 5 pi on 6. And that is going to be our answer. So what we just found is from here to here. That's what we just found. Let's give that a highlight. We just found this. So that means cos of x is equal to negative cos of pi on 6, and we know that x is equal to that. So if I can just show you what exactly we did here using our cas. Let's just bring our cas here for a moment. Let's bring this up. So what we're saying is that cos of x, we're saying cos of x is 5 pi on 6. So if I just come here for a moment, go cos, and then just type in 5 pi on 6, like that, I get that out. And what we're saying is that is going to be equal to negative pi on 6. And sure enough, it is. So negative pi on 6 is equal to negative the square root of 3 on 2. And cos of x, where x is 5 pi on 6, is equal to the same thing. So these two things are equal to each other. That's all we're doing there. So hopefully that makes sense. Let's now go on to the next one, which is a little bit more challenging. So again, what we're going to do, even before we look at anything, let's just bring across a unit circle. So just quickly sketch a unit circle for yourself, and you might find that this is just a more doable question. Okay, so it says if sine of theta is equal to negative sine pi on 7, and this is our domain, find the value of theta. The first thing I'm going to do is just graph sine pi on 7. So again, this isn't accurate at all. We're just going to give ourselves a rough sketch of what's going on here. So I'm going to do this. This is going to be pi on 7. It's going to be AB. Now, because I'm dealing with sine, that means I'm looking at the y value. So that means I care about b this time. So now let me rewrite what we've been given. So I'm trying to find sine of theta equals negative b. Well, I know that if b is here, then negative b, oh, sorry, that's wrong. B is my y, so b is here. B is there, so that means negative b will be down here, negative b is there. And I know that is what I know. And let me just quickly draw it in. So what I'm saying here is that this is going to be a negative b. Okay, so we have to find sine of theta equals negative b. And now here's the important part. It has to be within the domain of pi on 2 and 3 pi on 2. I know that pi on 2 is here. I know that 3 pi on 2 is here. So that means my angle needs to be between here and here. So that means it can't be in my fourth quadrant. So I need a negative b value out in either my second or my third quadrant. Obviously, I can't get any negative y values out in my second quadrant, so that's out. That leaves me with my third quadrant. So how am I going to find it? What I'm going to do is say, well, what it's asking me to find is simply this. Because this right here is going to be negative a, negative b. And that's what we want. We want that negative b. We know that the angle that we need to remember here is going to be pi plus the angle that we've been given, pi on 7. So that's going to leave me with 7 pi on 7 plus pi on 7 is equal to 8 pi on 7. So that's all based on my knowledge that I know that this right here is going to be pi plus the angle that I've been given. And that's what I know about the third quadrant. That means my answer here is going to be this one. So what we just figured out is from here to here. That's what we just got. If we now just wanted to double check what we did here, we would bring this up and I would say negative trig sine of pi on 7 is equal to that. And then if I go 8 pi on 7, whoops, oh, so let's do that again. I'm going to have to go Control Enter to get that out, and then this one, Control Enter, and as you can see I get the same result out, which means that these two things equal each other, so it all checked out in the end. Alright, so hopefully that made sense what I did there. It might be a bit intimidating at first, but the more examples we'll go through, the more comfortable you can feel about it. And if you are having trouble, please reach out. All right, let's now go through our last idea here, which is just talking about negative angles. And this is a great way to ease out of the lesson here. All right, so let's start by just saying that this is theta. And this is going to be AB right there. We know that A is going to be my cos, because it's my x. And my b is going to be my sine because it's my y. And now what we're going to do is we're going to consider a negative theta. So that means down here now, negative theta. Now, what is this negative theta going to be? Is my x going to change? No, my x stays the same. It stays as b, but my y changes, so it becomes negative b. That means I'm going to get cos of theta negative sine of theta. So it's really important that you notice that my sine changed, but my cos remained the same when I made the theta negative. So as I come over here now, what I'm going to say is when I have sine of a negative angle, it means I have negative sine of that angle. When I have cos of a negative angle, I just have cos of that angle. It stays positive. And then if I have tan of a negative angle, well, remember here that we're just going to be dividing these two. So it's going to be negative sine on theta over cos of theta. So it's going to be negative tan of theta there. And now, let's keep on going. We can come over here now and we can say, all right, If I have sine of x is equal to 0.6, let's remember our rule. If I have sine of a negative angle, that just means I have negative sine of that angle. And if I know that sine of x is equal to 0.6, then I can say sine of x is equal to 0.6, keeping that negative out there. So that means my answer is going to be negative 0.6. We come over here. When I have a negative x and I am dealing with cos, I know it's just going to be cos of that. It's like the negative just disappears. And I know that cos of x is equal to 0.8. So my answer is going to be 0.8. Then finally here, I know that when I have tan of a negative, that means it's just going to bring the negative out to the front. I now put in what I know it to be. And it's going to be negative 0.28. And that's how I approach those questions. Hopefully you found all that useful. I have a feeling that people will struggle with this because they do every year. It is a challenging idea, so we can talk about this later. All right, see ya.